Hello, this is Team 9, and we worked on extreme multi-domain multitask learning with unified text-to-text transfer transformers. I'll be walking us through from the problem to the conclusion. Multitask learning is basically using one model to learn multiple tasks. And while there have been attempts to do this within domains like NLP or very similar domains like code and natural language, there have actually been very little attempt to do this across very different domains. In this work, we try to build models that are sort of jack of all trades that could learn to do multiple tasks across extremely different domains. We do this by proposing the multi-domain text-to-text transfer transformer NTP5 that carries out 4 tasks across 2 domains, chess and code. Because we have 2 domains, our data collection also involves collecting data from 2 domains, and the data set statistics can be seen on the screen. Similarly, we have 2 baselines for the 2 different domains, the chess transformer and the code T5. We had 3 sets of experiments, which was a mixture of BERT style and GPT style joint pre-training and successive and joint fine-tuning. We had several metrics for the multiple tasks. We had the play score and the eval score to help us understand how the model understands chess playing and chess evaluation. We had the blue score to help us understand how the model understood code summarization and code generation. And finally, we have the multi-domain learning score, which is a F1-like score that helps us understand how well the model keeps its multi-domain knowledge. Here are our results. Across the 4 tasks and 4 metrics that we have, we see that our MDT5B model outperforms the baseline 3 out of 4 times. On code generation, where the model could not perform the baseline, we predict that this is because code generation is a very difficult task and will require much more training for us to achieve comparable results. Similarly, our model greatly outperformed the baseline on code summarization, and believe this is because the baseline was trained on multiple programming language and negative knowledge transfer may have happened because of this. Finally, the MDT5C model performs very well on multi-domain learning score, which tells us that it had the best ability in terms of keeping the knowledge from the multiple domains. Here are some of the sample outputs for the code tags. On the left, we see some sample output from the summarization tags, and we can clearly see that the output given by at least 2 of the models were as good as that of the target. Similarly, on the right, we have code generation, and we can see that the experiment B and C models actually gave reasonable code output based on just text fonts. We have reasonable names and reasonable code structure, and this shows us that the model actually learned something reasonable about code-related tasks. Furthermore, we move on to some generated positions by the model for chess. And while the positions in themselves do not carry any significant value, it just shows us that the model was also capable of doing a complex task such as generating chess moves for very long positions. In conclusion, we investigated the abilities of transformers to perform well across multiple tasks from multiple domains using a unified text-to-text framework by creating datasets from multiple sources and then carrying out 3 sets of experiments. Our key takeaways include that the MTT5 model hold up well against very strong baseline. The GPT-style joint pre-training and fine-tuning, that's C, showed the most promise because it was the one that could keep most knowledge of the multi-domain learning. And finally, we note that the negative knowledge transfer and catastrophic forgetting is still a major limitation, especially for the joint pre-training and successive fine-tuning experiment. Some future works that can be built on this work include application of other transformer training strategies, addition of more compute resources and additional training time, and scaling up the number of tasks and or domains. Thank you for listening.